I speak absolutely no German. I do apologize for that. And something got lost in translation, which is why something which is billed as the influence of marginal oil fields came across to me as reserves in fallow fields. So if anybody feels that they're here under false pretenses, this might be the opportunity to leave. We will therefore proceed with fallow fields and other questions. There we go. Reserves are a very uncertain thing, and there are probably 4 major sources of uncertainty in the published numbers. I'm not talking about yet to find, this is reserves in the ground. Firstly, we have uncertainties around definitions. What is oil? Do you include natural gas liquids? I mean, ethane, propane, butane, you don't really go and run your cars on this stuff. Do we talk about 1p, the proven reserves, or the 2p, the proven and the probables? A few people will talk about the 3p, proven and probable and possible. It's an uncertainty. There's uncertainties about price and cost. How much are you prepared to pay? Because clearly you can bring some more marginal stuff on stream as a reserve if you're prepared to pay for it. Then there's the growth of technology, the improvement in reserves growth, enhanced oil recovery, the various technological improvements that we expect to be coming down the road at us. Then the one that I'm going to focus on today, which is simply the accuracy of some of the reported reserve volumes. And can I say now that just because something is uncertain, it doesn't mean to say I'm prejudiced one way or the other as to whether it's too high or too low. It's just uncertain. And in these numbers, again, we have a 4-fold division. Where are the problems? Well, there's this one that we all know about, the OPEC Middle East numbers, which have been dodgy for the last 20 years. It's an old story. We won't go down that route again. There are producing fields whose claimed reserves appear to be way too high for their production rates. And if that's a problem for another day. But if anybody wants to look at it, go and have a look at some Nigerian fields, some of the old ones. Stacks of reserves they would have to produce for 75 or 100 years at current rates just to get it all out. I don't believe those reserves exist. Then we have the fallow fields, which are fields not yet scheduled for production. Now, some of these are counted as reserves, but they're probably not commercially producible. And then we have some developed fields which seem to be non-producing or don't have recorded production, and they also lead to reserves anomalies. Now, this is a bit of a mystery story. I hope you like mystery stories. In 2000, when I worked for BP, I was asked to do a projection of potential future oil supply. And I had access at that time to essentially all of the world's commercial fields databases. So I did this field by field from the bottom up, thousands and thousands of lines in a spreadsheet. And I extrapolated forwards. And you can see what the extrapolation looks like. It's that nice blue line above what I expected demand to look like. And there was a big bump in the future. Oh, the red circle was when I made that projection at the end of 2000. This hump suggested that there was no problem for the next, 15 years or so, getting on for 20 years, because there was a lot of stuff in the ground which we could go down, drill, switch on. And so I reported back to my masters in BP, that doesn't seem to be a short-term problem. And they said, can you do this next year? And so I did it next year, and I got the pale blue line. And I started to wonder, why was it that we hadn't actually produced some of this stuff in the ground? Because you can see, I haven't got a pointer here. I'm very sorry. If I was 8 feet tall, I could actually do this by hand. But anyway, we clearly hadn't followed the dark blue line of what was possible. And I thought, that's a bit odd. I've been running this model every year since, and here we are in 2012. You can probably guess what's coming up now. A friend of mine has unkindly christened this the Miller bump. It seems to be a block of oil which is never developed and yet is there in the fields database. It's got a little bit bigger over the years, not hugely bigger. Obviously, I've got more data over the years because you find little sources of data. So I'm happy that it should have grown a little bit. But it means that my projections of future supply are always the weird ones when you see a plot of lots of people's projections. Mine's the one with a big hump at the front. And the big hump at the front represents fields which are in the fields databases of the world which never seem to get developed. So, being a rational scientist, what's the problem? What do I do? The suggestion is that some potential fields are not being developed or produced, and what evidence exists for them? Data sources. You'll be familiar with the BP Statistical Review. You'll be familiar with Oil and Gas Journal, which gives some field data. It's quite nice, particularly the older ones. And this confidential fields database, like all confidential data, I get the pantsuit off me. Actually, the companies that say they own this data, this is a bit of an aside from this morning, they don't own it. Almost all data is owned by national governments. And if these people have got it, they're either licensed to issue it, or more likely they've got bootleg versions from, barroom deals. And when you pay your money to IHS or to De Gollier and McNaughton or whoever, I don't think you're actually buying their property at all. Anyway, I can assure you that the analyses that are done are numerical and objective. There is nothing subjective unless it actually says so. Okay. If we just very quickly compare what this fields database, which I relied on, looks like compared to some of the bigger ones. Okay, the BP Statistical Statistical Review, you've got sort of 1.38 trillion barrels, and it looks a little bit bigger than the sum of the fields database. But the fields database excludes onshore China, onshore Canada, onshore US, and all the Canadian oil sands. It also excludes NGLs. If you add that lot back in, this is actually quite markedly bigger than the Statistical Review, which is a country-by-country analysis. You'll be familiar with it, I know. So the first thing I did was to take this fields database and break it up by field status. So, fields listed as producing have 79% of the world's reserves. Fields listed as developing, redeveloping, temporarily shut down, 8%. You can read it. I don't need to go through it for you. And this analysis was done in my last days at BP, which were early 2008. Okay. I can't show you the data, but I can show you my opinions. That's legal. But here are the interesting ones. We have 6% awaiting sanction or in appraisal, and 7% as just listed as discoveries, of which I noticed immediately that quite a lot are quite old. So that gives us 173 gigabarrels, these two, which hadn't been developed by 2008, although clearly some of them will. That is not big enough to explain the Miller bump. The Miller bump looks as if it's about 150 billion barrels of stuff that just doesn't get developed year by year. So something else was going on. What else can be? Going further into the fields database, I found this weird anomaly. There's no real explanation for it except poor data. Many fields which were classed as producing have no recorded production. And they record a date when that non-existent production stopped. Okay. You can only deal with what you've got. So you deal with it. Possibilities then, some of these fields are producing, but they have no production data. This is not actually zero, this means it's null. You just don't have data. People don't understand the difference between zero and null. But if that's the case, it means that the remaining reserves will be overstated because production hasn't been subtracted from them. Some of these fields could be co-producing. This happens, you produce into a hub, and then the production just gets recorded against the name of one field. That should be net neutral on reserves overall. Some of these fields are temporarily shut in, but if they are, and we've gone through $150 a barrel oil, you've got to ask, why are they shut in? Because you wouldn't choose to shut something in when prices are at an all-time record. But these reserves may exist. Or the field has actually been abandoned and it's just not listed as abandoned, in which case the reserves do not exist. So this bumps up the quantity of questionable oil to 304 billion barrels. Now, I know, just from inspection, that at least 70 billion barrels of this lies in large fields which we know, which I know, are actively producing today. But nevertheless, we can start to analyse what's left. Okay, discoveries are now only 29% of this 304. Those fields awaiting sanction are under appraisal, 28%, but we now have these so-called producing fields, which contain 23% of this 304, and which have no recorded production. Now, where are these apparently dormant fields? This is just a few. I've just pulled some numbers out. So Algeria has 35 of these non-producing fields with 1.6 billion barrels of reserves. Angola usually has quite good data. And yet 16 fields are in this database with 3.7 billion barrels. Apparently these fields produce, but they have no recorded production. China, that one doesn't surprise me because all of these are offshore and they're run by Chinese companies. And you just can't get data out of China. You cannot even, I tried this once, you cannot get the dinner menu from an offshore drilling rig out to the Chinese authorities. Everything is a state secret. Finish. Indonesia would be the same as China. You cannot get data out of Indonesia. Iraq, I'm not surprised that this has 8 fields listed as producing with no recorded production. These fields have been probably temporarily closed since the Iran-Iraq war. And you can't be surprised, so I'm happy to put a big tick. I believe that one. Russia, state secrets. Saudi Arabia, probably fields they just haven't switched on. Quite happy to believe that. But look at this, UK. Probably the best data in the world. Sounds like a beer advert. 55 fields in this database have no recorded production and yet have reserves of 1 billion barrels. And this from some of the best data in the world. So I don't believe that exists. Okay, so there's a flavour of what's in this database then. Can we actually test to what extent we have null data, no data at all, or these fields are shut in, or they are co-producing in clumps? Well, you can do something. If it's null data, let's see if I can get this right. If it is null data, then the national total from the fields database should be too low compared to the national statistics put out by national authorities. So we can test 2 examples, Angola and Indonesia, summing up the field database and comparing it to BP or the Oil and Gas Journal. Do we get similar numbers? Well, that's the Indonesian case. So on the left here is the sum of the fields database by year, 2000, 2001, 2002. And there is the BP statistical reserves number, and there's the Oil and Gas Journal number. And what we find is that there is some suggestion that the fields database sum is a little low. But remember, this one excludes NGLs. And NGLs are included by BP and excluded by Oil and Gas Journal. So actually, when you look at that, when I look at it, I can just say I don't really see a problem. It looks to me as if these fields really are produced. The total production is where it should be. And so probably what you have is fields which are co-producing or which are genuinely being switched off. But it's not a case of null data. But this one is different. This is Angola. Angola is not a gassy place. This doesn't have NGLs. And year by year, the sum of the fields database is low compared to the other data sources. So this is a case where this well-known fields database, that we cannot name, is clearly not getting data. It is putting in nulls instead of zeros, which means that it is not subtracting production from reserves field by field, which means its estimate of Angolan reserves has to be too high. Right. That's enough of the detail. Let's just get down to the nub of the matter. How much do I question? Right. Oh, a bit of a big chart. Across the top, then, are these various classes of fields. So these are so-called producers which shut down, and it says producing until. Okay. Fields which are developing or temporarily shut in. Fields awaiting approval, fields awaiting appraisal, fields which are just discoveries, fields which have been abandoned, and the grand total of 304. Okay? These are all of the things, remember, in that fields database that have no recorded production. Here I have decade by decade, either when the field was shut in or when it was discovered, okay, which is that group there. So, I don't believe that anything that was shut in prior to the year 2000 and hasn't started since is really viable. It's been shut in for a very good reason. One or two minor exceptions like Sudan, where you have a bottleneck in the export pipeline, but mostly I think you have to look at these and say, these genuinely don't exist. These fields were shut down because they're not producible, they're not economic. I would say that we can do some more with this, and we'll have a look on the next page for this green group of fields which were apparently shut down between 2000 and 2007. Of the brand new discoveries, I reckon that if a field was discovered and before 1980 and still hasn't been submitted for appraisal, its reserves probably don't exist. They are theoretical. These are things which are not economic. And I'm not even sure about some in the next decade, from 80 to 90. So I'm going to take half of those. Sorry, awaiting approval, I should have said, not discovery. Fields which have been in appraisal since their discovery. I don't feel that anything that's been in appraisal up to 1990 and still hasn't actually made it off the starting blocks, I don't believe those reserves exist either. And I'm going to take half of the next decade. I don't believe that anything that has been discovered up until the year 2000 and has had no further work done on it is likely to actually be real reserves, because somebody would have done something on it. Remember, this the subsequent decade had those high oil prices of 150. You would run anything that was possibly viable. In fact, on these discoveries, I will also take anything discovered up to 2002, it's another 2 years, and any tiny field discovered up to the beginning of 2008. If no further work has been done on these fields, I don't think that that is really available oil. Just going back, well, yeah, okay, we're there. Just going back to this green group, these are fields that have been shut in that period of time, between 2000 and 2007. Where are they? Well, those which are in Angola, the deep water stuff from Brazil, Iran, Iraq, Saudi, Sudan, and the Corocoro in Venezuela, I'm prepared to accept that they exist. They're not being produced, some of them are, but I'm prepared to say that they probably exist. But these remainder, if they're not being produced, it's because they're not producible. So I'm going to count those too. If you add up all of the red in this slide and the previous slide and half of the orange, I'm getting a number of 138 billion barrels of reserves, which are there in the records, okay? We depend upon these databases. And yet 10% of it is stuff that you really can't justify. And really, that's the summary. I can find 138 gigabarrels of reserves, which is about 10% of the world's reserves, which are highly, highly uncertain. And, I'm not going to put hand on heart and say they don't exist. I'm just saying I don't think they are, for the most part, commercially producible. Some hasn't been developed for too long. Some of it has been produced but not recorded. And some of it's been abandoned and may even reflect original overestimates of reserves. And that's it. Thank you for your time.
Do people have questions ready to go? Excellent. So Thomas is going to help with some microphones. I might go to the question at the back there, and then we'll come to Jeremy after that.
Roger Bentley, visiting researcher at Reading University. A very nice presentation, Richard.
Thank you.
I always find it a little difficult to follow everything. I understood there were quite a lot of fields in the Middle East that hadn't yet been connected up, don't even have pipelines going to them. Where do they stand in this analysis, and what's your views on that?
Oh, wrong way. Well, some of them in Iran, Iraq, and Saudi, not plumbed in. I'm quite prepared to believe that these really exist, that they are producible, that it's a case, in Saudi's case, of wanting to put them on stream. And it's a case in Iraq's case of getting the infrastructure repaired before they can go back on stream. And also, knowing that you put half a dozen holes through one of these big Middle Eastern fields is enough to prove that it does exist and is producible, but doesn't mean to say it's ready to switch on. There's a lot more work that has to be done on some of these, but they are genuine reserves. They do exist.
Can I just clarify? Is that one? Can I just clarify? Is that it is working?
This testing 1 2 3.
That's okay. The point is, the figures that you're showing are fields that have been listed as producing. So at some point, they've changed status from, they're not just being discovered, they're not just appraised, but they're actually, somebody's ticked a box and said this meets some threshold for producing. How does that reconcile with fields that have never been tied into infrastructure before?
Running some test production in the first or second well into a field, and you can read the press reports, can't you? You know, did 5,300 barrels a day over an 18-hour test. You know, it's a number. And our little friends from DeGolyer and McNaughton run out and write it down in their notebooks, and it goes into the database. And until it's replaced with better data, that's the number that stays there.
Okay, and so in most cases, a company that does a production test on a well won't class it as producing, but sometimes...
Data is data.
For whatever reason, companies will choose to report that as producing.
It would appear to be that way. I can put no other explanation on some of these anomalies.
Okay, well, I don't know if that clarifies it for anybody else, but it does help me. We'll pass to Jeremy.
Well, Richard, first of all, thank you for a very interesting paper, because I've never seen anyone address anything like this before, and I think it's great work. A comment, first of all. I'm probably a bit older than most people in the room, and I was around when Shaif and Zakum were discovered in the UAE, and certainly the message from the Abu Dhabi government at that time was to look at depletion rates of less than 2%. So these very low depletion rates you're talking about in some areas of the world may well be real. But my real question is, when you're talking about reserves here, I'm not sure what your definition of reserves is. Are you talking about proved, probable, possible, PUDs?
I'm sorry. I shot through the second slide rather fast. In this fields database, these are 2P reserves. They are listed as 2P.
Okay.
So proved and probable.
Okay. So when you talk about a field having been discovered, I mean, if you just drill a well, you can only put class as reserves the oil within a very short distance around that well. So I'm not quite sure how this works in your study.
I think the people who fill in the numbers on this database would say, yes, if you're in America, you can only do a sort of 50-metre or 100-metre radius around the well. But if you're anywhere else in the world, you prove the field with seismic and a well. The seismic then gives you the volume, and the well gives you the certainty that you can produce it. And this is how BP works.
So these are not SEC-type reserves?
These are not SEC. Yeah. These are definitely 2P reserves.
Thank you. But still, congratulations on a very original and interesting paper.
Take one up the front here, and then to the person at the back.
Thank you. Just a question of clarification for a non-specialist. What is shut in? Redefine it, if you could. Thank you.
Okay, shut in means that the field is left mothballed, if you like. So it could be turned on, in theory, but for whatever good reason, it's not operating at the moment. It can be anything from what's called a workover, which is when you just need to refresh the physical condition of the wells, you re-drill them, reline them, penetrate them. Or in the case, as I say, of Iraq, this could be a field that was forcibly shut down back in Operation Sandstorm or whatever it was, and it's just no one has ever been sufficiently motivated and empowered and enriched enough to go and get it all back into working order again.
At the back?
Just at the very beginning, you showed the curves of what you call Miller's hump. And
yeah. Do you want to see it again? Makes me laugh.
Well, the 138 that was on that very last slide that just disappeared, does that come out of the hump? And if so, how much does it reduce it?
It pretty much takes out the hump. It leaves about 20% of the hump behind. That's not bad.
So there's still a hump, but not anywhere near as much.
I would always expect a small hump because of the lead times involved. in making those plots, I assumed extremely short 1-year lead times for the first fields to be brought on stream. In reality, most lead times are 3, 4, 7, 8 years. So
Okay.
I always expect a little hump.
So do you have, from your new analysis then, do you have a point where your projections cross the demand line? And if so, what is it?
No, I don't. Because the way I produce these curves, they are now frozen in time. So I can no longer change the way the modelling is done and retain the early data. This is a lesson I will learn for the future. Always leave yourself flexible. But as I say, I froze the numbers and I can't change them. They're just listed in a database now.
Fair enough.
That was a great question, very key point to come away from the presentation to clarify that. We'll put our hands together for Richard. Thank you very much.